welcome to Night Sky News for June 2021 with me, astrophysicist Dr. Becky Smethurst. This is the series where we chat about what you should look out for in the night sky in the coming month, and we chat about what's been happening in space news in the past month. All of the news stories are linked in the little chapter titles below, so you can skip ahead if you want, and any scientific research papers I mentioned will be linked in the video description down below. But without any more further ado, let's kick things off and start by looking up. So we are very close to the solstice now on June 21st, which means that there's not a lot for us to see up here in the far reaches of the Northern Hemisphere because we got a lot of day and not a lot of night right now. So a lot of the things I've picked out this month are going to be for those of you who are a little bit further south than the UK and have a better chance of spotting these things. So for example, on the evening of the 23rd of June, Mars is going to pass right in front of a star cluster known as the Beehive cluster, or M44, which means you'll be able to see both objects in a pair of binoculars at the same time, and it's going to look spectacular. But this is only really going to be visible for those of you south of the UK, probably about south of about 40 degrees north, to be honest, because when Mars and the Beehive cluster are up, it's essentially still daytime for us. But, you know, if you're further south, you'll have a much better chance. It'll be higher above the horizon just after the sun set, and then you'll have a couple of hours before Mars and the Beehive cluster set together to actually be able to spot this. The night after, on the 24th of June, we actually have the last supermoon of the year. This is when the moon is closer to us in its orbit during its full moon phase. And note the media will probably dub it a strawberry supermoon due to the names from the Farmer's Almanac again. You know, they're just the names for the full moons in each month. Strawberry is not an astronomical term. Sadly, the moon will not look like a strawberry, alas. Then I've got something for all of you with a telescope and probably looking for an excuse to break that telescope out. So on the night of the 26th, two of Jupiter's moons, Io and Callisto, will be passing in front of Jupiter and casting a shadow onto its surface. So this is going to be visible for those of you sort of in Eastern Northern America and for all of Central and South America as well in the wee hours of the morning on Saturday, the 26th of June. So around 1 a.m. Eastern time, Io will start to cast a shadow on Jupiter, pass by the slower moving Callisto's shadow about 2:25 early in the morning, and then move off at around 3:22 a.m. Eastern. So if you fancy a late night on, the Friday the 25th of June going into Saturday the 26th of June morning, then this is the perfect excuse and it will be well worth it. Then in the days that follow, on the 27th, 28th and 29th of June, the just past full moon is going to come close to Saturn first, and then in the middle, and then Jupiter. And this should actually be visible wherever you are in the world, if you at least have nighttime at the minute, from around midnight to just before sunrise. Now, the closer to the equator you are, the better view you will have because the higher they will actually rise in the sky throughout the night. Here in the UK, they're going to be quite low on the horizon, so difficult to spot if you've got sort of houses and trees around. But if you can spot it, you should particularly look for it on the 27th when the moon is close to Saturn, because actually it'll be close enough that you can fit, again, both the moon and Saturn into a single field of view of binoculars. So that should make finding that little yellow dot of Saturn that little bit easier if you're not sure what you're looking for. Now, the next thing I want to talk about is technically not stargazing, but it's interesting. On the 5th of July, Earth will actually hit what we call aphelion. It's furthest point from the sun at around 4.8 million kilometers further away than when it's at perihelion, its closest point to the sun, in January. And I think it's just a really nice reminder that it's not distance that causes the seasons, it's the tilt of the Earth's axis. But back to the night sky now for one last thing, because it wouldn't be a night sky news if I didn't bring up a toenail moon, and this month is no exception. However, this month is actually competing with something just as cool, and that is that Venus and Mars are going to come within 1/2 degree of each other on the sky. So this is on the 13th of July, just after sunset, and essentially Venus and Mars will be about the width of a full moon apart, and you'll have Venus incredibly bright, Mars just that little bit dimmer, but very red looking next to it, and then this really thin, just sliver of a toenail moon, or a crescent moon to give it its proper name, just above them. So look towards the direction of the sunset just after sunset on the night of the 13th of July, and as long as you've got a nice clear horizon, you should be able to spot this. The further you are from the equator, the lower down they're going to be on the horizon, so you have to be higher up to actually spot this. But if you're on the equator, they'll be really nice and high in the sky and be around much longer after the sun sets as well, so you can actually spot this. So that's all I have for looking up for this month. Now let's come back down to Earth and chat about what's been happening in space news in the past month. All right, I just want to start with mentioning a few news stories that I'm just going to touch on, but I'll put links in the description if you want to know more about them. Let's start off with the Dark Energy Survey, which this month released 3 years worth of observations, cataloguing 226 million galaxies to essentially give us a map of how normal and dark matter is distributed in the universe. I actually dedicated a whole video this month to talking about that news story because there was just so much to talk about in terms of what we learned about the nature of dark matter and dark energy as well. So if you haven't seen that yet, and my interview with Dr. Alex Amon from the Dark Energy Survey collaboration as well, go check that out. I'll link it in the video description and up here in a card somewhere too. Speaking of videos that I have made recently as well, you might have also caught my video on the James Webb Space Telescope. And in that video, I said, now it's set for launch on the 31st of October 2021, and we have all got all of our fingers and toes crossed that that actually goes ahead. Apparently, I seem to have jinxed it because NASA and ESA have announced that the launch is probably going to get put back. Now, this is nothing to do with the telescope itself, it's actually due to the rocket that it's going to be launched on. So this is ESA's Ariane 5 rocket, and it's still grounded after the issues it had with the release of sort of the payload covers last year, going through a redesign at a minute, and there will be 2 more launches of it before Webb launches later this year. It's just so frustrating that now the telescope is ready and has gone through all the tests and it's about to be put on a bloody boat to be shipped to French Guiana. There's just something else that's delayed it. I guess it's just sod's law at the end of the day. Anyway, in other news, the Canadian Space Agency also announced that this month they noticed that the robotic arm that they have on the International Space Station was hit by a tiny piece of space junk. And it left this tiny little hole that was first spotted on the 12th of May. That debris piece must have packed a right punch because that thing is clad in Kevlar, as in like bulletproof material, and the inside of it is made from titanium. Thankfully, everything is still working okay with the robotic arm as far as they can tell, which is a good thing, because the ISS is essentially reliant on this robotic arm for maintenance of the outside of the International Space Station, moving equipment and payloads and astronauts about as well. I think it's just gonna be one of those things that's a not so friendly reminder that space junk in low Earth orbit is becoming a real issue and a real danger to things like the space station, and we should definitely do something about it. All right, let's talk space missions now. We haven't sent a probe to the surface of Venus since the Soviet Union's Vega probes in 1984. NASA hasn't landed a probe since the Pioneer missions in 1978, and there's currently only 1 operational satellite in orbit, which is JAXA's Akatsuki, after ESA lost comms with the Venus Express back in 2014. Compare that to the plethora of satellites in orbit around Mars and the probes that have landed on Mars even in just recent years. But Venus just got a whole load more interesting last year in 2020 when astronomers announced that they discovered phosphine in the atmosphere of Venus. Phosphine is kind of like ammonia, but phosphorus's version. It's pH 3. And now since then, a discovery has come out contesting that discovery of phosphine. So you've sort of got like 2 warring papers essentially at the minute trying to claim 2 different things, because there is a lot of hype around this phosphine discovery, and that's because we don't know many ways that can produce phosphine. We know here on Earth it's produced in industry and also by tiny microbes. So yes, while it's very likely that the phosphine on Venus is probably being produced by some unknown chemistry or some unknown geological activity down on Venus, there is also a very, very tiny, slim chance that it might be produced by microbial life in Venus's atmosphere. And so that's why there has now been a sort of huge interest for going back to Venus within the scientific community. And so the people who work on studying Venus have essentially been begging space agencies for a new mission to Venus for many, many, many years. And it's just like buses, right? You know, you wait around for one and then three turn up at once, because that's what's happened this month. So NASA have announced 2 new missions to Venus this month. Veritas, which is planned for launch in 2028, which will orbit Venus to sort of map the surface with radar and spectroscopy to try and get at its tectonic history, so the plates and the volcanic activity, and any interesting geochemistry as well that's going on. Secondly, you've got the Da Vinci Plus mission, which is an atmospheric probe planned for launch around 2030 to investigate actually what's going on in the atmosphere itself, where there's that contested phosphine discovery. And then ESA, the European Space Agency, also announced plans for their Envision mission to Venus with a launch schedule for about 2031. This is another orbiter doing radar imaging of the surface, but also these atmospheric studies to try and investigate the specific processes that made Venus so different to Earth. So there's lots of new and exciting missions to look forward to, but it is worth pointing out that before NASA and ESA announced these plans to go to Venus, ISRO, the Indian Space Research Organization, already had a mission to Venus planned for launch in 2024 that was an orbiter, and Roscosmos, which is the Russian space agency, also had an orbiter and a lander mission planned for launch in 2029. So, you know, NASA and ESA aren't the first to plan to go back to Venus. There was already plans in the works from other space agencies. But I guess what it means is that Venus is going to become a hive of activity very, very soon. Let's switch our attention to Mars for a little bit now. And last month's Night Sky News just missed out on talking about the successful landing of the Zhurong rover on the surface of Mars on the 14th of May, 2021. It's actually the Chinese Space Agency's first probe to land on the surface of another planet. So a huge congratulations to the whole team for that achievement. It was actually jettisoned by the orbiter Tianwen-1, which arrived in orbit around Mars in February 2021. And it's got a similar mission objectives to NASA's Perseverance, which was already on the ground, in that it's searching for signs of life and looking at the chemical composition of rocks, but it's also specifically searching for water ice in those rocks as well, and working out the sort of proportion of water ice in the rocks on Mars. After it landed, it was actually spotted on the ground by NASA's Mars Reconnaissance Orbiter satellite, and it's been sending back its own images from the surface too, from its position on the Utopia Planitia. Here's one when it was still on its landing platform. It stayed on there for about a week or so, and then it took its first drive rolling down this ramp off the landing platform, which we then got a glimpse of when it took an image back towards that landing platform after its first little drive on the surface. You can even see the rover's wheel tracks there as well. Then it dropped a little wireless camera on the ground and rolled back next to that little landing platform and took, let's call it a selfie for want of a better word, right? But it really is just beautiful to see it there on the surface, and it really reminds me so much of WALL-E here. WALL-E. So it's been on the surface for around about a month now, going through all the checks and the commissioning stages and all that kind of stuff, and I'm really looking forward to seeing what it finds as it starts to rove more widely on the surface now. It's due to last for about 90 days, so I think they're planning to cram as much as they possibly can into that time. While we're on Mars, let's talk about Ingenuity, NASA's little helicopter drone thing. A complete success story so far, right? But its 6th flight didn't go as well. So we communicate kind of like a flight path for Ingenuity, like through Perseverance, who relays the message essentially to sort of rise to a certain height, travel so far in a certain direction, and then land again. But Ingenuity's got sort of like an onboard computer to adjust its speed and its acceleration based on the conditions it's flying in and any changes to the terrain that it records using its little navigation camera that looks downwards. But during the 6th flight, something went a little bit wrong with that onboard computer. And it started to pitch and roll all over the place. Now, thankfully, it landed safely after this, so it's all still intact. But NASA still don't really know why this happened. There's going to be a little bit of a scramble to analyze all the data that they got from that flight to work out what went on and what went wrong, and if there is anything that we can do to fix it. But it might throw a little bit of a spanner in the works for the plan for Ingenuity to assist Perseverance as it starts to rove further afield. There's actually a great blog post all about this sixth flight from the chief pilot of the Ingenuity mission for NASA on the mission website that I'll link down below. All right, let's move on to some astronomy research news now. And I want to start with this study that's come out this month that's claiming that there is not a planet around Barnard star. So Barnard star is one of the closest stars to Earth after Proxima Centauri at about 6 light years away. And way back in November 2018, a study came out claiming they had found evidence for a planet around Barnard star. And I even remember covering this study in one of the very first Night Sky News videos I made for this channel, way back in November 2018. And in that video, we chatted about how what Rebus and collaborators had done in that study is grab about 20 years worth of archival data and see if they could see anything periodic, a periodic signal in there that would be a planet looping around every, couple of years or whatever it might have been. And what they found was that they found a signal that was repeating every 233 days in that archival data. And they attributed that to a planet that was about 3 times the mass of Earth, so something we would call a super Earth. So they did this using a radial velocity measurement. So this is where you actually look for a wobble of the star on the sky. And that's because, it's not just the planet that orbits the star and the planet both orbit this little center of mass between them. And usually that's actually in the star itself. So all you see is a little wobble of the star. And you can tell that it's doing that from the light of the star, because you actually see this Doppler shift, a red shift and a blue shift as the star wobbles away and wobbles towards you. Now this month, there's a new study come out from Lubin and collaborators, and they took more precise radial velocity data with the Habitable Zone Planet Finder instrument on the 10-meter Hubble Telescope at McDonald Observatory in Texas. And they took it over 856 days. That's about 2 years and 4 months worth of data. So if there was a planet going around every 233 days around the star, we would definitely spot it. But Lubin and collaborators claim that they did not see any periodic signal over 233 days, and in fact saw no periodic signal that would suggest there was any planet around Barnard star at all. So what did Rubin and collaborators in 2018 spot in their data then? So Rubin and collaborators actually looked into this. They grabbed the same archival data and found that 233-day signal was coming just from data taken from about 2011 to about 2013. And so when they looked into this, they found that actually the star itself was more active in that time. And so it will have had more star spots or sunspots like on the sun. And that could actually have contributed to this periodic signal that Rebus and collaborators claim to have found and attributed to a planet rather than just star activity changing. So as exciting as it would be to have a planet around a very nearby star only 6 light years away, I think this study by Lubin and collaborators might have just squashed that hope. All right, now for something completely different. Fast radio bursts. Fast radio bursts are extremely short, incredibly powerful bursts of radio waves, and they generate the same amount of energy as the sun does in an entire year, but in a fraction of a second. It's kind of crazy. And since the first one was discovered back in archival data taken in 2001, we've clocked about 1,000 more of these things, but we've only been able to trace back the locations of where these fast radio bursts actually came from in about 15 of them. So it makes figuring out what's actually generating these fast radio bursts very difficult if you haven't got an idea of where they came from in the universe. Back in May 2020 though, one was actually traced back to a magnetar in our own Milky Way. This is a special type of neutron star that's formed as a star dies and goes supernova, but it has a huge magnetic field and they're very chaotic and very unpredictable. Now this month, using the Hubble Space Telescope, Mannings and collaborators have actually tracked down the host galaxies of about 8 of these fast radio bursts, including 3 that have repeated as well. Those are even weirder. And they found that 5 are actually found along spiral arms in their galaxies, which is interesting because they're found not nearest the brightest spots in the ultraviolet, where we know that a lot of new young stars are forming, but they're also not found near the brightest spots in the infrared, which is where all of the older, smaller stars that are much longer lived are found. So they're somewhere in the halfway house between the youngest and the oldest stars, which would make sense if it was magnetars that were generating these fast radio bursts, because you need to wait a couple of billion years before you get a neutron star, and also a magnetar as well. So this result kind of confirms the idea that maybe fast radio bursts are being produced by these very chaotic and unpredictable magnetars. So maybe that might be one unsolved mystery that we can cross off the list very soon. All right, let's chat about black holes for a bit, because lately astronomers working on ESA's LISA space-based gravitational wave detector, planned for launch in 2034, have been asking the public on social media for suggestions for names for a collection of black holes, because we don't have one. And so many of you tagged me in this on Twitter as well, which was great to see. And great also to see the plethora of suggestions that were sent in, from the silly to the, oh, that would make so much sense. And now the LISA team have narrowed it down to their 10 favorites and are asking people to vote by ranking the 10 suggestions, essentially. I'll link this site in the description below if you'd like to vote, because the vote is still open. I personally don't like the words with negative connotations to them, you know, things like gloom and brood and disaster as well. You know, I think for one, it just adds to the misconceptions around black holes, but also black holes are really cool. We can't call them as something as like sad sounding as gloom, you know? I'm not going to tell you what my favorite word is of that list, because I don't want to like bias the vote in any way, although I guess I kind of just did with the words I don't like, but I don't want to bias it in favor of the word that is my favorite. But I will be irrationally sad if the word I have been using for a collection of black holes all this time doesn't come out on top. Irrationally sad. Anyway, speaking of black holes, or perhaps the lack of them, a paper by Becerra and collaborators that came out this month has claimed there isn't a supermassive black hole at the centre of the Milky Way. Now, they're still arguing that there is an object at the centre of the Milky Way that is about 4 million times the mass of the sun, like we think the black hole is, but they're arguing that it's not a black hole, it's just a clump of dark matter. So last year, the Nobel Prize in Physics for 2020 was won for measuring that mass in the center at, 4 million times the mass of the sun, using the stars orbiting around it. So by observing the positions of these stars over decades and then studying their orbits and working out what they are, you can work out how heavy the thing is that they're orbiting around. You can also figure out how strong gravity is in that region. Essentially, you can test whether space is as curved as much as general relativity, Einstein's theory of general relativity, predicts for a black hole, and we find out that yes, it is. That curvature matches our model of what a black hole would look like under general relativity. I actually made a video all about that Nobel Prize win from last year, which again, I'll link in the video description below and up in the cards here. But a spanner was thrown in the works back in 2014 when astronomers held their breath as a gas cloud dubbed G2 appeared to be falling into the black hole. And we were excited because we didn't get to watch this approach the event horizon in real time, and we expected this huge big flare of X-rays as well as that gas got superheated, and none of that really happened. And the gas cloud essentially came about 260 times the distance between the Earth and the Sun from the event horizon of the black hole, and it just looped around it, got stretched out by its pass-by, essentially, and now we also think it's experienced a drag force, which is all very weird and not what we would expect at all in that model of a black hole in general relativity. Now, it could just be that our observations of this gas cloud and its position and distance from the center, the black hole, are not very precise. This thing is 26,000 light years away after all, and you've got to look through a hell of a lot of dust towards the center of the Milky Way to actually be able to see this thing as well. So that could explain some of it, but Becerra and collaborators proposed this alternative hypothesis that the mass in the center isn't a black hole with an event horizon, it's just a big blob of dark matter. So what they did was that they took those observations of the stars orbiting the center, and they took sort of the 17 closest in and tested whether those orbits fit a model that was just a clump of dark matter that was causing the curvature of space and therefore the gravity. And then they also took the observations of G2, this gas cloud, and worked out whether that sort of positions and orbit and looping round would also match this blob of dark matter rather than a black hole. And they found out that, yeah, they did. The maths kind of checks out, which is really interesting. And it could explain a couple of different things. One of them being the fact that the Milky Way's black hole, what we call accretion rate, so the amount of matter it's sort of eating every year or growing by, is a lot lower than we would expect for a black hole of its size compared to sort of what we see elsewhere in the universe. But they also suggested that when this dark matter blob reached a critical mass, it would be dense enough to actually collapse down into a supermassive black hole itself. So something, instead of 1,000,000 times the mass of the sun, like in essentially the Milky Way, something that was 1,000,000,000 times the mass of the sun, say around about the mass of M87's supermassive black hole that the Event Horizon Telescope imaged a couple of years ago, something like that could be formed in that way. Because that would nicely explain how supermassive black holes form, because we still don't know how they managed to actually grow so big if they start in the early universe, say, from something where a star's gone supernova and produced a black hole of, say, 5 to 10-ish times the mass of the sun. There's literally just not enough time to produce these supermassive black holes at billions of times the mass of the sun in such a short space of time. So I kind of feel like this idea of the center of the Milky Way being a blob of dark matter rather than a black hole is very interesting, because it would nicely explain certain things that currently aren't explained. But I also have this slight worry that it's almost just, it's too neat almost. It's almost like too convenient in a way. I think more analysis and more results and more time will tell, obviously, and allow us to figure this out. In particular, I'm really excited to see the Event Horizon Telescope's image of Sagittarius A star, the black hole at the center of the Milky Way, like they did with Messier 87. They're trying to do that with our center of our galaxy. Whether that is a black hole or not, we'll see. And it's proving very, very difficult because, as I said before, you have to look through so much dust to see towards the center of the Milky Way, and that's creating all of this sort of emission in the foregrounds it's hard to get rid of. So that's why it's taking them a very, very long time. They're being very, very careful with their analysis. But I think once that image does come out, it'll be worth the wait, because it really will allow us to test these different ideas with a different data set again. You know, we've done it with the stars, we've done it with the gas cloud. Okay, so what does the Event Horizon image tell us instead for the curvature of space, and what is there? I think this is a really, really interesting idea. And yeah, it's one of the things that's going to keep me awake at 3 a.m. in the morning. All right, that's it for Night Sky News for this month. If you can't wait another month for your space news fix, then you can follow me over on Twitter and on Instagram, where I post about news stories as they happen, but also just, you know, friendly little reminders about things that are upcoming in the sky to look out for as well. But until next time, everybody, wherever you are in the world, happy stargazing. Now, phosphine is kind of like the phosphorus version of ammonia. It's pH3. Is it pH3 or have I just made that up? Remind myself, because I'm not a chemist. Hey, I was right. Coal, because, you know, this thing is 26,000 light years away, and you've got to look through a hell of a lot of dust towards the center of the Milky Way. Irrationally sad. You know, like flipping tables, storming out of the room, refusing to ever work in astronomy again. Levels of sad is probably too far, to be honest. I'd probably still work in astronomy again, but I would be irrationally sad about it, and I would make it known in all of the papers that I write. Center of the Milky Way, they're stealing my black hole away from me now.